Before we go any further, we need to understand what an algorithm is. To put it simply, it's just the steps required to do something, and that something could be pretty much anything, whether it be a maths problem, whether it be building something, or cooking something. Speaking of cooking, recipes are algorithms, so let's try one out for ourselves. Take two containers. We'll name them cup and pot. Now, if we're talking from the perspective of a computer, these containers represent the computer's memory in a way. In a program, the computer needs containers to store things. Now, computer would be storing data, we'll be using our containers for something a little bit different, but what we tend to call these storage places are variables. When we're working with variables, we need a name to refer to them so that the computer knows which piece of data we're talking about. What thing are we talking about? In our case, the names would be cup and pot. A small little side note, there are some rules and best practices for setting variable names. For example, variables can contain both letters and numbers and underscores, but they can't ever begin with a number. And there must be absolutely no special characters. And there's also a list of names which we can't use because Python has reserved them for other things. These are called keywords, and you can see a list of them here. And that's about it for rules, but there are some best practices. When you're selecting a name for a variable, you want it to be meaningful, like cup and pot. Using X and Y, while it is valid, it's very confusing if you don't know what the information at X and Y represent. Also, when working with multiple words for variable names, we can use underscore to bridge that gap because spaces aren't allowed in variable names. There's also other ways of dealing with that by capitalizing the start of a new word, and you can play around with that, figure out what style works for you, but just make sure that within one program or one project, you don't mix and match styles. Next up, we're going to empty our containers. This step is normally called initialization, and it's necessary because when computer gives us memory to work with, it doesn't clear it out for us, and we don't know what it was being used for before. And it'd be pretty undesirable if our cups and pots already had paper tape and cocoa inside. So yeah. Next up, we'll be adding 150 milliliters of water and 150 milliliters of milk to our cup. Now, this is typically known as an assignment statement since we're assigning contents to our containers. Initialization is also a type of assignment. Also, that phrase to the right side, 150 ml of water plus 150 ml of milk, is an example of an expression. And an expression is just the value or the content that we're assigning to a variable. After that, we're going to go ahead and transfer the contents of the cup into the pot. Now, one thing to keep in mind is that when computers transfer contents from one container to another, they actually make a copy of it. And so in our digital world, the cup would still actually be full of milky water. Oh, and let me just add a spoon of sugar. Now, next up, we're going to have to heat it until it starts boiling, which means until we start seeing bubbles. Now, this is a bit more of an advanced code structure, which we'll get into later, but basically, we're constantly checking if it's starting bubbling, and if not, we're just going to continue heating it. Now, when it does start to boil, we need to lower the flame and add our patti to the pot. What you'll notice is when adding the patti, I have mentioned the pot on the right side of the statement too. That's because the right side describes all of the contents of my pot. And since I want to add the patti on top of what the pot already has, I write it like this. Then I wait for a bit more before turning off the flame and then transfer it to the cup, making sure to remove the patti. And there you go, our first algorithm. Now this won't exactly run in Python because the syntax here isn't very precisely accurate. For example, the contents of the cup at the start, water and milk, aren't really defined as any of the data types we have. They're not strings because they don't have quotes. They're definitely not integers or floating points. So that's going to be a bit messy. But that's the general idea of how an algorithm works. Also, you'll notice that near the end, I started using these words with brackets. Now, these are called functions. They're like mini programs and they can do stuff for us. We'll get into them with a lot of detail soon, but for now, let's just leave it at that. Now, one difference you may have noticed from this lecture versus the last is that our program was not in this black box, and in fact, it was multiple lines at a time. And now this is called script mode. The idea here is that when I'm working in command line and I'm writing statement at a time, it's going to be very annoying if I have a very long program because I'll have to enter in each step individually. What would be nice is if I had all the steps somewhere and the computer would just go through them on its own without me having to type them in each time. And that's called a script, and it's going to be very handy because as you write longer programs, not only tiring to write, If you end up with an error, you'll have to start all over. Although to write scripts, you're going to need a text editor, but it's better to have an IDE, which is an integrated development environment, can help you do a little bit more than just writing and executing your code. So Visual Studio Code is a very popular IDE. Now I've told my IDE I'm using a Python file using the .py extension. And so the benefits of that is that if I were to write something like name equals hello, you'll see that hello is being highlighted in green. And then when I try to go ahead and print the name, it's going to give me the name as a recommendation to write because it knows I've made a variable called name. Also, if I change my mind later on, I can go ahead, highlight this, and then I can rename the symbol to greeting, and it updates it wherever it finds it. Now an IDE has a lot of features, so take it slow, customize it to your preferences, but do look into it because it's a very handy tool for developers. Now I'll be using Python a lot to do math, so it helps to understand the order of operations. What we mean by order of operations is, will this multiply first or will this add first? Now, it's not too tricky because it follows the rules that we have in normal mathematics. And what that means is that if I have any brackets, that's going to be evaluated first, then any powers, then after that it'll be division or multiplication, and then finally we'll have addition and subtraction. And we can remember this by remembering the word BEDMAS, which means P for parenthesis, E for exponent, D for division, M for multiplication, A and S for addition and subtraction. If we were to evaluate our expression, so the bracket gets evaluated first, which gives us 3, then 3 is raised to the power 3, and we have this now, 3 power 3 divided by 15 plus 4 times 2 minus 10. So then we'll do the next set of steps. So this becomes 27. And then after this becomes 27, we can do the division on this. So 27 divided by 15, which would give us 1.8, I think. We're not going to remove the plus sign just yet. We're going to get rid of the multiplication. So that becomes times 8. And the minus 10 would also just get copied as is. And then finally, we'd solve this, which should be negative 0.2. And so let's put that into our terminal. And yeah, now you'll notice that the answer is slightly off. And that's just because of how computers store numbers. They can't always store the number to complete accuracy, so they try their best, and then whatever is left due to the limitation of their memory, that just gets approximated. Also, a small little thing, if you have multiplication and division, it's just going to evaluate from left to right. So it's going to do 8 times 8 first, which is 64, and divide by 2 to give us 32. And that example is pretty readable, but if we were to do something like 8 divided by 2 times 8, for us it might be confusing whether the 8 is multiplying with the denominator, whether 8 is multiplying with the result, but it multiplies with the result, and that's because this part gets evaluated first and then the multiplication gets evaluated. But what's recommended is that whenever you have an expression and you're not completely sure what's going to happen first, just add a bracket. The benefit of that is I have more control. So if I instead wanted to do the addition first, I can do it like this, and voila. Next up, let's talk about string operations. Now we touched upon this a bit last time, that different data types have different operations. With integers, you can add, subtract, divide, multiply, just like you would do in maths. With strings, it's a little bit more different. So it's clear that I don't know what subtracting a string would be, or dividing a string would be, or multiplying two strings together would be. But could you guess what would happen if I try to add two strings? It just joins them together. It doesn't add any spaces, which is pretty handy if I want to be very specific, but it means in the case if I'm mentioning two different words, I have to add a space manually. And this process of adding strings is actually called a string concatenation, in which a string is added to another end to end. Now we could even store these strings in variables and do the same thing like done here. So we store throat in first and warbler in second, and we add first and second, and we get the joint word throat warbler. So addition, simple enough. But what's very interesting and a bit weird at first, but really fun to play around with, is that multiplication also works. But I just mentioned it doesn't. Well, it doesn't work between strings and strings, but it works between strings and integers. If I write spam multiplied by 4, it's going to print spam 4 times. And you can see where I'm going with this. And my terminal looks disgusting now, but it does give me a power trip to know I have just written 40,000, 400,000 words, I don't know which one. With this great power comes great responsibility. Don't crash your computers, although I don't think you can. But this is a very nice tool to have because it lets us print out patterns more easily. And when we get around to doing loops, you realize that loops can do the same thing. Sometimes this is actually shorter and easier code to read and write. And it's also a different way of approaching problems, which is a good skill set to build upon. Finally, now that our code is getting longer and longer, you might face issues where you open up a program and you don't know what's happening. For example, I've named this temp. I will not know what it's doing until I read the 2 lines of the code. What I can do is instead of reading the code, I can add a comment. For example, says hello. And that's telling me that this program says hello. Now, what you might want to do is if you have a longer program, instead of writing a comment which tells what the whole program does, you can write comments for each chunk of program, and that will help you understand how each bit is working so that when you want to reuse that or if you want to change that chunk, it's more easier for you to navigate that. It's also easier for anyone else who's reading your code. Plus, it'll make the process of debugging so much smoother. In fact, I'd argue that when you're trying to code a solution, just write down your process in comments so that you know what you want to do. But despite all that, you're going to run into errors. So now we talked about syntax errors last time, and that's like, for example, if I added a space accidentally, it doesn't recognize that. But there's also other types of errors. Now, one very well-known example is if I try to divide a number by 0, and it's going to tell me 0 division error because the computer doesn't know how to divide by 0. And to be fair, I don't either, so I can't blame that. Another example of a runtime error is like if you call the name of a variable, but you've never initialize that variable. You've never mentioned that variable before, and now you're asking for the value of that variable. Well, the computer doesn't know what the value of cup is because I've never mentioned cup in this program at least. And the third type of error, probably the one which costs the most sleep, is a semantic error. Unlike with syntax errors and runtime errors, you don't get told where the errors happen. If I wanted to check the number 9 is greater than 5, and I got the answer false. The program ran to completion, but it didn't give me the answer I wanted. I know that 9 is bigger than 5. And so in those cases, what I'll have to do is I'll have to go back through my code, search each line and find that error, and then correct it so that my program works as I wanted it to. There are tools in your IDE which help you deal with those errors. These are called debugging tools. So let's take that same program, write it here. One thing you'll notice is that I've used a print statement here instead of just blankly writing 9 is less than 5. That's one of the differences between script mode and terminal mode, is that in script, if you type in an expression, it's going to give you the result of that expression. For example, 9 is lesser than 5 is false. But in an IDE, it's not going to do anything with that. It's going to evaluate it inside of the program, but it doesn't know whether to output it or what to do with it. So you're going to see no results. But if you encapsulate it inside of a print statement, and I've added a breakpoint, which I can do by left clicking over here, and then I go into run and start debugging. Now my program's going to run, and it's going to run step by step, and it's going to stop where my breakpoint is. Now what I can do here is I can add an expression to see the value of that expression. So 9 is less than 5, and I see that that is false. Now that can help clue me in that maybe it was my expression which was wrong. And so what I can do is I can stop running my program, or I can just complete its execution by clicking that down arrow. Now I can change it to 9 being greater than 5. Also, I'm just going to add a handful of extra print statements here. Then I'll go back into debugging and I'll add an expression 9 is greater than 5, and I see that's true. So that gives me confidence, and then my program prints true. Now one thing you'll notice is that I pressed this down here and it took me to the next statement that's going to execute, and then the next statement, and the next statement. And so that way I can go through each step, find out where the error is, and this is very handy for longer programs. And this is one of the best perks of using an IDE, along with its various customizability. And now that you understand how scripts work and how an algorithm works, it's time for you to practice your skills on the review exercises. It'll help you understand the use of variables and how assignment statements work. Speaking of the use of variables, it's really handy when you need to store data that you know you're going to use later. For example, the user gives me the radius of a circle and I want to calculate its area. I need a way to store that radius so that I can include it in my later calculation. For example, if I set r to be equals to 5, and then I set area to be equals to pi, which I write as 3.14 times r to the power 2. And because of order of operations, I know r power 2 will be evaluated first, but I'll include brackets just to make that clear. And now I can print my area, or I'll write it as print area, and that's going to give me my area. So here, storing it in a variable made it easier to work with. With that said, happy programming.